what do we actually know about aliens? Beyond the Hollywood depictions of green beings with oval-shaped heads and a penchant for peace signs, the truth about extraterrestrial life remains one of the greatest mysteries of our time. For decades, we've speculated, theorized, and even fantasized about what might exist beyond our world. Yet, despite our endless curiosity, concrete evidence of alien life has always seemed just out of reach, until now. Our understanding of the cosmos has evolved dramatically over the centuries, and with it, our approach to the search for alien life. We've learned to look beyond the surface, exploring not just what alien life might look like, but how it might survive, where it could be hiding, and what signs we should be searching for. From the earliest telescopic observations to the latest data from space telescopes and probes, we've been piecing together a picture of what life beyond Earth could be. But what do we really know? We've developed sophisticated methods to find life, analyzing everything from the atmospheres of distant planets to unexplained phenomena in our own skies. We've searched for biosignatures, chemical fingerprints of life on distant exoplanets, and we've studied the conditions necessary for life in regions like the Goldilocks Zone, where planets are neither too hot nor too cold. We've even investigated the possibility that advanced civilizations might not dwell on planets at all, but in colossal structures like Dyson Spheres. Despite these efforts, the question remains, are we alone in the universe? The answer could be closer than ever, as modern science continues to push the boundaries of what we know. We've found tantalizing clues, mysterious signals, and unexplained phenomena that keep us searching, keep us hoping. But to truly understand what lies beyond, we must start at the beginning. So first, let us start in the 17th century, when Galileo Galilei pointed his telescope towards the heavens and forever changed the way we look at the moon. In the early 17th century, a simple yet groundbreaking invention changed the way humanity looked at the universe. Galileo Galilei, the renowned Italian astronomer, pointed his telescope towards the moon, revealing its surface in unprecedented detail. What he saw sparked the imagination of an entire generation. The moon, once a distant and mysterious orb, now appeared closer and more tangible, with dark patches across its surface that looked strikingly similar to Earth's oceans. These dark regions were soon named Maria, the Latin word for seas. It was a natural assumption at the time. If these were seas, perhaps they might also harbor life, just like the vast oceans on Earth. The idea of moonlings, hypothetical beings living in these lunar seas, began to take root. People speculated that the moon, far from being a barren rock, might be home to creatures that swam in its waters, hidden from view by the great distance between our worlds. But as our understanding of the cosmos deepened, so too did our knowledge of the moon's true nature. With more advanced telescopes and scientific inquiry, it became clear that the Maria were not seas at all. They were expansive plains of dark basalt, formed by ancient volcanic eruptions that had filled large basins on the moon's surface. These plains, while fascinating in their own right, were devoid of water, atmosphere, and life as we know it. The moonlings, it turned out, were nothing more than a product of our imagination, a reflection of our deep-seated hope that we were not alone in the universe. Yet, this early speculation marked an important moment in our history. It was one of the first times humanity seriously considered the possibility of life beyond Earth. The dream of Moonlings was, in many ways, the beginning of a long and ongoing journey, a journey driven by curiosity, wonder, and the relentless pursuit of knowledge. Today, we know the Moon as a desolate, airless world, its surface scarred by impacts and shaped by ancient volcanic activity. But the story of the Moonlings serves as a reminder of the power of human imagination and the boundless possibilities that exist when we look up at the night sky. It was a small step in our exploration of the universe, but one that paved the way for all the questions and discoveries that would follow. As we continue to search for life elsewhere in the cosmos, we must remember that our first steps into the unknown were filled with dreams and visions of what might be. The Moonlings may not have been real, but they were the spark that ignited our quest to find out who or what might be out there. By the 1870s, humanity's gaze had shifted from the Moon to a new celestial target, Mars. The red planet, with its rusty hue and mysterious surface features, had long been a source of fascination. Among those captivated by Mars was the eminent British astronomer William Herschel, whose meticulous observations led him to some intriguing conclusions. Herschel was a man of precision. He carefully measured Mars' size, noting its smaller diameter compared to Earth. He observed the planet's seasons, which were remarkably similar to our own, and he calculated the length of a Martian day, finding it to be only slightly longer than a day on Earth. But it was Mars' lower gravity that truly piqued his interest. If life existed on Mars, Herschel reasoned, its inhabitants would likely be much taller than humans. The reduced gravitational pull would allow their bodies to grow to greater heights, unburdened by the constraints that gravity imposes on Earth. This idea of mighty Martians captured the public's imagination. The thought that Mars might be home to towering beings, vastly different from anything on Earth, fueled a growing fascination with the possibility of extraterrestrial life. In an era when science and speculation often walked hand in hand, Herschel's theories provided fertile ground for the imagination. People began to envision a world where Martians strode across the plains of Mars, their elongated forms perfectly adapted to their alien environment. But as the years passed and our understanding of Mars grew, Herschel's vision of towering Martians began to fade. More detailed observations revealed a planet that was cold, dry, and inhospitable, a far cry from the world of giants that had once been imagined. The idea of tall Martians became a footnote in the history of astronomy, a reminder of how our understanding of the universe is constantly evolving. Yet, Herschel's theories were not without their significance. They marked an important moment in our exploration of the cosmos, highlighting the idea that life on other planets, if it exists, could be vastly different from our own. The concept of alien life as something that might not just resemble humans, but could be shaped by entirely different forces, opened the door to new ways of thinking about the universe and our place within it. In the 18th century, philosopher Immanuel Kant introduced a theory that shaped the way people thought about extraterrestrial life. Kant proposed that the intelligence of beings on different planets was related to their distance from the Sun. He suggested that the scorching heat of Mercury would limit the intellectual development of any life forms there, while the cooler, more distant Saturn would allow for the growth of highly intelligent beings. Kant's idea, known as the hierarchy of intelligence, was based on the belief that a planet's environment directly influenced the capabilities of its inhabitants. According to his theory, beings on Saturn, the superior Saturnians, would possess greater intelligence than those on the inner planets, due to the more favorable conditions farther from the Sun. At the time, this theory provided a structured way to imagine life beyond Earth, aligning with the limited scientific knowledge of the period. Kant's ideas suggested that the farther a planet was from the Sun, the more advanced its inhabitants might be, influencing how people of that era viewed the potential for life in the universe. While modern science has since disproven this theory, showing that intelligence is not determined by a planet's distance from the Sun, Kant's work was a significant early attempt to understand the possibility of alien life. His ideas reflected the evolving curiosity of the time, and they marked an important moment in the journey toward a more scientific exploration of the cosmos. In 1848, Scottish church minister and science teacher Thomas Dick took a bold step in the search for extraterrestrial life by attempting to calculate just how many beings might inhabit our solar system. At a time when much of space was still a mystery, Dick's approach was both imaginative and methodical, reflecting the growing interest in understanding the cosmos. Dick speculated that if the population density of extraterrestrial beings mirrored that of England, approximately 280 people per square mile, then the vast expanse of the solar system could theoretically support a staggering 22 trillion inhabitants. His calculations, though speculative, were based on the assumption that life could thrive on other planets in the same way it does on Earth. This alien census, as it came to be known, was far from accurate by today's standards. Modern science has shown that the conditions necessary for life are far more complex and rare than Dick assumed. Nonetheless, his work was significant for its time. It marked one of the earliest attempts to quantify the potential for life beyond Earth, moving the discussion from mere speculation to something that could be analyzed and estimated, however imperfectly. Dick's calculations, while ultimately incorrect, underscored a growing curiosity about the possibility of life elsewhere in the solar system. They reflected the spirit of an era eager to explore and understand the universe, even if the tools and knowledge available were still limited. His work contributed to the ongoing conversation about extraterrestrial life, paving the way for more sophisticated approaches in the years to come. By attempting to count the inhabitants of the stars, Thomas Dick exemplified the expanding human desire to understand our place in the universe. Though we now know that his estimates were far off the mark, his efforts were an early indication of the lengths to which humanity would go in its quest to discover whether we are alone in the cosmos. As the 20th century progressed, our search for extraterrestrial life extended beyond the planets to their moons. While Mars had long been the focal point of speculation, modern science shifted its gaze to the icy moons of Jupiter and Saturn, Europa and Enceladus. These distant moons, once thought to be barren and inhospitable, emerged as some of the most promising candidates in the hunt for alien life. Scientists discovered that beneath the thick icy crusts of Europa and Enceladus lie vast oceans of liquid water, kept warm by internal heat sources generated by tidal forces from their parent planets. This realization marked a significant shift in our understanding of where life could exist in the solar system. No longer was the search confined to planets with Earth-like conditions. Now, even the coldest, most distant moons were considered possible havens for life. The comparison to Earth's own deep oceans added further intrigue. Here on our planet, hydrothermal vents on the ocean floor support vibrant ecosystems, teeming with life that thrives in the darkness, far from the warmth of the sun. These ecosystems are powered not by sunlight, but by the chemical energy released from the Earth's interior. The discovery of such life forms led scientists to wonder, could similar hydrothermal vents exist on Europa or Enceladus, sustaining alien creatures in the darkness beneath the ice? This idea of life in the hidden oceans of these distant moons continues to capture the imagination of scientists and stargazers alike. Missions to these moons, such as NASA's planned Europa Clipper, aim to gather more data and perhaps even detect signs of life. The exploration of Europa and Enceladus represents the next frontier in our search for extraterrestrial life, expanding our understanding of where life might exist and what forms it could take. By focusing on these icy moons, modern science has broadened the scope of the search for life beyond Earth. Europa and Enceladus remind us that the universe is full of surprises and that life might thrive in places we once considered impossible. The hunt for life in the distant moons of our solar system is a testament to humanity's relentless curiosity and our desire to explore every corner of the cosmos in the quest to answer the ultimate question: are we alone? As the possibility of life on the icy moons of Jupiter's Europa and Saturn's Enceladus gained traction, scientists began to speculate not just about the presence of life, but about its potential forms. If life does exist in the vast, dark oceans beneath these moons' icy crusts, what might these alien creatures look like? The answer, as it turns out, might be more familiar than we think. Simple physics suggests that in the deep, dark oceans of these moons, any large aquatic life forms would need to move quickly to catch prey and evade predators. The need for speed in a fluid environment often leads to streamlined shapes, just as we see in Earth's oceans with creatures like squid, dolphins, and sharks. These animals have evolved to glide effortlessly through water, their bodies perfectly adapted for hunting and survival in a world of constant motion. This idea has led to the tantalizing possibility that if life exists on Europa or Enceladus, it might take on similar forms, perhaps long, slender creatures with flexible bodies, capable of rapid movement in pursuit of prey. Scientists have even coined a term for these hypothetical beings: space squid. While purely speculative, the concept of space squid offers a fascinating glimpse into the potential diversity of life beyond Earth. As our exploration of these moons continues, the hunt for such extraterrestrial creatures becomes one of the most exciting prospects in astrobiology. Missions designed to probe the oceans of Europa and Enceladus may one day provide us with direct evidence of life, evidence that could reveal not only that we are not alone, but that life can take on forms both strange and familiar in the most unexpected places. As our understanding of the cosmos deepened, the search for life moved beyond our solar system to the broader expanse of the Milky Way. Advances in technology and astronomy opened our eyes to the vast number of distant worlds scattered throughout our galaxy. The discovery of exoplanets, planets orbiting stars outside our solar system, marked a significant turning point in this search. By the early 21st century, astronomers had identified over 3,800 exoplanets in our nearby stellar neighborhood. These discoveries led to an astonishing estimate. The Milky Way could harbor as many as 40 billion Earth-like planets. These are worlds located in their star's habitable zone, where conditions might be just right for liquid water to exist, a key ingredient for life as we know it. The implications of this discovery are profound. If even a fraction of these planets are truly habitable, the number of worlds capable of supporting life could reach into the billions across the galaxy. This realization has fueled the imagination of scientists and the public alike, transforming the search for life beyond Earth into one of the most compelling quests of our time. The vastness of these possibilities challenges us to think differently about our place in the universe. No longer is the search for alien life confined to the moons and planets of our solar system. Instead, it spans the entire galaxy, from the stars nearest to us to those on the farthest reaches of the Milky Way. As telescopes and detection methods continue to improve, our ability to find and study these distant worlds will only grow. Each new discovery brings us closer to answering the ultimate question: is there life beyond Earth? The sheer number of potential Earth-like planets suggests that the answer could be yes, and that somewhere among the billions of stars in our galaxy, other forms of life may be waiting to be found. As our search for distant worlds expanded, the next logical question arose: how do we detect life on these far-off planets? The answer lies in the search for biosignatures, specific signs that indicate the presence of life. In the vastness of space, where direct observation of life forms is impossible with current technology, scientists turn to the chemical fingerprints that life leaves behind. Biosignatures are often gases that are associated with biological processes. On Earth, for example, a wide variety of organisms, from termites to cows, release methane as a byproduct of digestion. However, methane can also be produced through non-biological processes, such as volcanic activity. This duality makes methane a tantalizing but challenging biosignature. Its presence alone is not enough to confirm life. To strengthen the case for life, astronomers look for methane in combination with other gases, such as oxygen and ozone. On Earth, these gases are produced through complex interactions with sunlight and biological processes. Oxygen, in particular, is highly reactive and would not persist in large quantities without being continuously replenished by living organisms. The simultaneous detection of methane, oxygen, and ozone in the atmosphere of an exoplanet would be a strong indicator that life, possibly even complex alien life, could exist there. Finding such a combination of gases on an exoplanet would suggest that something similar to Earth's biological processes might be at work. This could range from simple microbial life to more complex organisms, and in the most optimistic scenarios, even intelligent alien life forms. The presence of these biosignatures wouldn't just suggest life. It would hint at a planet with a thriving ecosystem, potentially harboring a wide variety of alien species. The search for biosignatures is a meticulous process. Using advanced telescopes, scientists analyze the light that passes through the atmospheres of distant planets, looking for specific patterns that reveal the presence of these gases. This technique, known as spectroscopy, allows us to detect the chemical composition of exoplanetary atmospheres, even from light years away. The detection of biosignatures on an exoplanet would be a groundbreaking discovery, offering the first real evidence that we are not alone in the universe. It would signal the presence of life, however primitive or advanced, on a distant world, fundamentally changing our understanding of the cosmos and our place within it. While we may not immediately know what kind of life exists, the discovery of these signs would be the first step in unraveling the mystery of alien life. In the quest to find alien life, one of the most critical factors astronomers consider is the location of a planet within its star system. This brings us to the concept of the Goldilocks Zone, or the habitable zone, a region where a planet is not too close nor too far from its star. In this zone, conditions could be just right for life to thrive, with temperatures that allow liquid water to exist, a key ingredient for life as we know it. The idea behind the Goldilocks Zone is simple. Planets that are too close to their star will be too hot, boiling away any potential water. Those that are too far will be too cold, freezing water into ice. But planets that lie within this zone have the potential to maintain a stable environment where water remains liquid, a crucial condition for supporting life. One of the most exciting discoveries in recent years is Proxima Centauri b, an exoplanet located in the habitable zone of Proxima Centauri, the star closest to our Sun. Proxima Centauri b is just over 4 light-years away, making it the nearest exoplanet with the potential to harbor life. While much about this planet remains unknown, its position within the Goldilocks Zone makes it a prime candidate in the search for alien life. But the Goldilocks Zone is not a guarantee of life. It's merely a starting point. Even within this zone, other factors such as atmospheric composition, magnetic fields, and geological activity play crucial roles in determining whether a planet could support life. However, focusing on planets within the habitable zone gives astronomers the best chance of finding worlds where life might exist. Now that we have a clear understanding of how we search for alien life, through the detection of biosignatures, the exploration of habitable zones, and the study of distant worlds, we can move forward into real-world examples of where these efforts intersect with the mysterious and the unexplained. The search for extraterrestrial life isn't confined to distant planets. Sometimes the questions arise right here on Earth in the form of unidentified aerial phenomena, or UAPs. In 2022, the investigation of UAPs entered a significant new phase. What was once relegated to the fringes of scientific inquiry has now become a serious subject of study, bolstered by advanced technology and heightened interest from both professionals and the public. The US government, recognizing the need for a more systematic approach, took a major step forward when President Biden signed the National Defense Authorization Act. This act included the establishment of a dedicated office specifically tasked with analyzing UAP data. This office represents a new era in the study of these phenomena. It's an acknowledgement that UAPs, whatever their origin, deserve rigorous, methodical investigation. The focus here is on real-time detection, tracking, and measurement, using the latest technology to gather data that could provide new insights into what these objects are and what they might mean. While the primary goal of this office is to understand UAPs from a defense and security perspective, the implications for the search for alien life are undeniable. These efforts could potentially lead to breakthroughs in our understanding of the unknown. Whether UAPs are advanced human technology, natural atmospheric phenomena, or something else entirely, the systematic collection and analysis of data will bring us closer to answers that have long eluded us. What else do we know? Well, as our exploration into the unknown deepens, new information continues to emerge, sometimes from the least expected sources. In April 2022, a significant release of documents under the Freedom of Information Act shed new light on the U.S. government's interest in UFOs. The U.S. Defense Intelligence Agency disclosed 1,574 pages of UFO-related material, bringing to the public eye details that had long been shrouded in secrecy. These documents, originating from the Advanced Aerospace Threat Identification Program, included a range of reports, some of which detailed injuries allegedly caused by encounters with unidentified flying objects. The cases described physical effects such as burns, brain damage, and nerve injuries attributed to what were termed anomalous vehicles. The very nature of these reports and the fact that they were documented by a government agency adds a layer of credibility that has intensified public interest and speculation. While the process by which these reports were vetted remains unclear, their release has sparked considerable debate about the true nature of these encounters. Are these injuries the result of experimental human technology, natural phenomena, or something beyond our current understanding? The ambiguity of the reports leaves many questions unanswered, but it also opens the door to possibilities that extend far beyond the mundane. The disclosure of these documents has not only reignited discussions about UFOs, but has also highlighted the ongoing mystery that surrounds them. Despite the information provided, much remains unknown. What are these anomalous vehicles? Who or what controls them? And what do these encounters mean for our understanding of the universe? These declassified reports represent just a glimpse into the broader efforts to understand phenomena that defy easy explanation. They remind us that the search for answers often leads to more questions, and that the boundaries of our knowledge are constantly being tested. With the knowledge we've gathered, it's time to revisit one of the most profound questions in our search for alien life: the Fermi paradox. This paradox, named after physicist Enrico Fermi, asks a simple yet unsettling question. If the universe is so vast and teeming with potential for life, why haven't we encountered any signs of advanced civilizations? In 2022, this question received a new and grim proposal. Scientists suggested that the reason we haven't made contact with alien civilizations might be rooted in their own downfall. One theory posits that advanced civilizations, much like our own, might collapse under the immense pressure of their energy demands. As these civilizations grow, their consumption of resources might spiral out of control, leading to environmental degradation, societal collapse, or even extinction before they ever reach the stars. Another possibility is stagnation. Rather than collapsing, some civilizations might reach a technological plateau where their advancement slows or even stops altogether. This stagnation could prevent them from achieving the capability for interstellar travel or communication, leaving them isolated within their own star systems. Alternatively, a more optimistic yet still sobering theory suggests that advanced civilizations might undergo a homeostatic awakening. In this scenario, instead of pursuing endless expansion, these civilizations might choose to focus on sustainability and balance, prioritizing the health of their planet over the drive to explore the cosmos. Such civilizations might deliberately limit their energy use and technological expansion, making them harder to detect. This theory leads to a haunting conclusion. Many of the signals we might eventually detect from other civilizations could be from those on the brink of collapse, or from societies that have chosen a path of self-restraint. Instead of finding thriving, expanding civilizations, we might discover echoes of their final moments, or worlds that have turned inward, focusing on survival rather than exploration. Something exciting just happened in June 2022 that sent waves of anticipation through the scientific community. China's 500-meter aperture spherical radio telescope, known as FAST, made headlines with the potential detection of signals from an alien civilization. These narrow-band radio signals, which stood out against the background noise of the cosmos, initially appeared promising. Perhaps, at last, the breakthrough we've been waiting for. However, the excitement was short-lived. Upon closer examination, the signals that sparked so much hope were attributed not to distant alien technology, but to something much closer to home: human interference. Whether from Earth-bound radio transmitters, satellites, or other sources of terrestrial noise, these signals were not the long-sought evidence of extraterrestrial intelligence. Instead, they served as a stark reminder of the immense challenges we face in our search for genuine alien contact. This incident highlights the delicate and complex nature of the search for extraterrestrial life. With so many sources of interference and false positives, distinguishing between human-made signals and those that might originate from an alien civilization is an arduous task. Even with the most advanced technology, the quest to find true signs of alien life is fraught with obstacles, requiring careful analysis, patience, and a bit of luck. The FAST incident underscores the need for rigorous standards in the detection and interpretation of signals. While it's easy to get caught up in the excitement of a potential discovery, the reality is that most signals we detect are more likely to have mundane explanations. Yet, this doesn't diminish the importance of the search. It only makes the moments of genuine discovery all the more valuable. In 2022, scientists proposed a bold idea. What if some of the most advanced alien civilizations don't dwell on planets at all? Instead, they might inhabit Dyson Spheres, colossal megastructures built around stars to harvest their energy. These structures would provide not just power, but vast artificial habitats where entire civilizations could thrive. The concept of a Dyson sphere, first theorized by physicist Freeman Dyson in the 1960s, envisions a shell or swarm of satellites surrounding a star, capturing its energy output for the use of an advanced civilization. As stars like our Sun eventually transition to white dwarfs, these civilizations might construct Dyson spheres to continue harnessing energy, ensuring their survival in the later stages of a star's life. But how would we find such structures? The answer lies in the faint signals they might produce, tiny dips in the light from stars as these megastructures orbit and obscure them from view, or unusual infrared signatures indicating massive energy use. However, detecting these signals is no easy task. The sheer scale of a Dyson sphere means that even the most advanced telescopes might struggle to pick up on these subtle clues. The search for Dyson spheres around white dwarfs is a long shot, but it's one that could provide groundbreaking insights into the existence of advanced extraterrestrial life. If we were to detect such a structure, it would be a clear indication of a civilization far beyond our current capabilities, one that has mastered the energy of an entire star and constructed an artificial world in the process. So, what do we have to look forward to in our quest to understand the unknown? Well, in 2022, NASA made an announcement that marks a significant step forward: the launch of a dedicated scientific study into unidentified aerial phenomena, or UAPs. This move signals a new, methodical approach to investigating these mysterious objects, an approach that blends rigorous scientific inquiry with an openness to the unknown. The study, spearheaded by a panel of experts including former NASA astronaut Scott Kelly, is designed to identify and analyze UAP data. For decades, UAPs have captured the public's imagination, often fueling speculation about their origins. But until now, there has been little concerted effort from the scientific community to systematically study these phenomena. NASA's initiative represents a turning point as the organization applies its considerable resources and expertise to the challenge. The goals of this study are clear: to gather reliable data, develop a deeper understanding of UAPs, and ultimately provide insights that could help explain these phenomena. By approaching the study of UAPs with scientific rigor, NASA aims to move beyond the realm of speculation and into the realm of measurable, testable facts. What makes this effort particularly exciting is the potential for new discoveries. As NASA delves into UAP data, there's a possibility that we might uncover new knowledge not only about these objects but also about the broader workings of our atmosphere and the universe. The study might reveal previously unknown natural phenomena, or it could bring us closer to answering the long-standing questions about the existence of extraterrestrial technology. Over the coming years, this study is expected to provide fresh insights and a more comprehensive understanding of UAPs. While we can't predict exactly what NASA will find, the very act of applying scientific scrutiny to these phenomena represents progress. It's a step towards demystifying what has long been seen as one of the greatest enigmas of our time. What are we doing now? Well, as our search for extraterrestrial life continues, scientists are turning their attention to a new and intriguing possibility: the hunt for alien artifacts within our own solar system. In 2022, researchers speculated that advanced alien civilizations might have already visited our cosmic neighborhood and that they could have left behind evidence of their presence. These potential artifacts might not be immediately recognizable. They could be ancient spacecraft, probes, or debris from long-gone missions, now disguised as ordinary comets or asteroids. To the untrained eye, they would blend in with the natural objects that populate our solar system. But with closer inspection, using advanced imaging technology and spectral analysis, these remnants could reveal themselves as something far more extraordinary. The idea that alien civilizations might have left behind physical evidence is both tantalizing and daunting. Discovering such artifacts would be direct proof of extraterrestrial visits, offering a concrete link to beings from beyond our world. It would provide a glimpse into the history and technology of civilizations that may have explored the stars long before humanity even existed. Detecting these artifacts is no easy task. Our solar system is vast, and the potential artifacts could be small, distant, or hidden among countless other objects. But with ongoing missions and the continuous improvement of our detection capabilities, the search is intensifying. Scientists are carefully scanning the skies, looking for objects that don't quite fit the natural patterns we expect, objects that could be relics of alien technology. This search is a logical extension of our quest to understand the universe and our place within it. While the discovery of alien artifacts might seem like a long shot, it's a pursuit that carries immense potential rewards. Finding such evidence would revolutionize our understanding of the cosmos confirming that we are not the first to explore this region of space. The best proof? Well, we've all seen the YouTube videos, grainy footage of unidentified objects darting across the sky, often accompanied by excited speculation about their origins. But in October 2022, U.S. Department of Defense officials offered a more grounded explanation. They concluded that most UFO sightings, including some of the most famous cases, were not alien in origin at all. Instead, many of these sightings were attributed to what they called airborne clutter. This term covers a wide range of mundane objects that can be mistaken for something more mysterious, everything from weather balloons to Chinese surveillance drones. Even some of the most compelling reports, like the infamous 2018 U.S. Navy video that seemed to show an object defying the laws of physics, were re-examined and explained as optical illusions or sensor glitches. These findings highlight an important truth. In the study of unidentified aerial phenomena, or UAPs, careful analysis and a healthy dose of skepticism are crucial. The excitement that comes with the possibility of alien encounters can sometimes cloud our judgment, leading us to see what we want to see rather than what's really there. The reality, as these recent conclusions show, is often far less sensational. While the debunking of these UFO sightings might be disappointing to some, it's a necessary step in the scientific process. By ruling out the more mundane explanations, we can focus our efforts on the cases that truly defy explanation, those rare instances where something genuinely extraordinary might be at play. The conclusions reached in 2022 serve as a reminder that the truth is often more complex than it appears. Not every strange light in the sky is evidence of extraterrestrial life, but that doesn't mean the search is futile. On the contrary, it underscores the importance of rigorous investigation, ensuring that when we do find something truly remarkable, we can recognize it for what it is. In the end, the process of debunking these UFO mysteries brings us closer to understanding the real phenomena behind the sightings. It's a step towards separating fact from fiction, helping us focus on the true unknowns that remain, and there are still plenty of those to explore. Lastly, let's unveil our best chance of finding alien life, a mission that could change everything we know about the universe. In 2022, the James Webb Space Telescope provided groundbreaking insights that brought us closer than ever to answering the age-old question, are we alone in the cosmos? Webb's capabilities allowed scientists to analyze the atmosphere of the exoplanet WASP-39b in unprecedented detail. By building a comprehensive chemical profile of this distant world, researchers took a significant step forward in determining whether such planets could harbor life. The data gathered didn't just provide a snapshot of WASP-39b's atmosphere, it opened up new possibilities for studying other exoplanets with the potential to support life. But the most promising target in Webb's sights is the TRAPPIST-1 system, a collection of 7 Earth-sized planets orbiting a nearby star. Of particular interest is TRAPPIST-1e, a planet that lies within the habitable zone where conditions might be just right for life to exist. With Webb's focus on this system, scientists are hopeful that we might soon discover concrete evidence of life beyond Earth. The TRAPPIST-1 system represents our best chance of finding alien life in the near future. Its proximity to Earth, coupled with the advanced observational power of the James Webb Space Telescope, makes it a prime candidate for study. The possibility that one or more of these planets could host life is tantalizing, and the data we gather could revolutionize our understanding of the cosmos. This ongoing exploration is more than just a scientific endeavor. It's a quest to find our place in the universe. The discovery of life on another planet, even in the simplest form, would be a profound moment in human history. It would confirm that life is not unique to Earth and that the universe is teeming with possibilities we've only just begun to explore. As the James Webb Space Telescope continues its mission, we edge closer to the answers we've sought for generations. The potential to discover alien life isn't just a distant dream. It's within reach, and with each new discovery, we move one step closer to unveiling the mysteries of the universe.